value. What happens if you add $20, just like we just did, right? What happens if I were to add $20 to every single random variable? We said the mean, the expected value, would go up by that same amount, right? So whatever our old expected value was, it would go up by whatever that number I added in, 20 in that case. What happens if I subtracted? It would sing, right? But the standard deviation didn't go up. The standard deviation stayed the same because there was no increase in the spread. The spread was exactly the same, right? So the standard deviation would stay right where it was. What variance would do? What is variance? Okay. So if standard deviation squared isn't going to do this thing that standard deviation does. So the variance always does the same thing standard deviation does. Doesn't do anything different. It's the same thing. It's just the squared number, right? So the variance would stay the same. Okay, so the next one, the a in front of the x. That's the same question, but doing this instead. Instead of adding $20 to it all, let's say instead they multiplied everything by 2. They multiplied everything by 2. They doubled all of the prizes. What do you think the new average would be? What do you think the new average would do? If I doubled all of the prizes, it would double as well. It would double as well, right? So I would take whatever A is and multiply it times the old expected value. So the old expected value was $6.37. We said $6.37. If I were to double everything, the new expected value would be $12.74. Okay. What about standard deviation? What about standard deviation? Would that double or would that stay the same? So it stayed the same before, right? It stayed the same before because I didn't widen or close my arms, right? Well, let's see now. Let's do that same thing now. Before I had $5 to $100, right? Now what's the new low number? $10, right? So it moves a little bit up. Where's the new high number? What's the range from 5 to 100? 95, right? What's the range from 10 to 200? It got bigger, right? My hands are going to go out further. So standard deviation is actually going to increase this time. Okay. So how much is it going to increase? By the same number. So whatever the old standard deviation was, it's going to multiply by that guy. Same thing with variance because the spread is now increasing. Okay. So the question they're going to ask you on a test is they're going to want to know, did standard deviation increase? Did mean increase? Did they both increase? Did one of them increase? Well, what did you do? Did you add or subtract everything by a number? Or did you multiply everything by a number? If multiply, they both get bigger or smaller. Same thing, if I were to half all of these guys, if I were to decrease the prizes and say half, this is $2.50. This is $7.50. This is $12.50. This is $50. What happens to the spread? It's going to get half as wide, right? So you multiply everything by a half or divide everything by 2, right? Okay. So that's what they're going to do. They're going to give you the same problem, but now they're going to change it up a little bit and say, oh, nope, the numbers are going to change. So you got to determine whether the mean is going to get bigger or smaller and how much. Variance is going to get bigger or smaller. Standard deviation is going to get bigger or smaller. Okay, that's one of the things. That's called transformations, transforming. The other one is combining. Let's say we have 2 lists. Kind of like you have on number 3. You don't have to flip to it yet because we're not going to do it right now. But I have 2 lists for number 3. I have 2 tables. What if I were to combine the 2 tables? How would I figure out the mean and standard deviation? So if I were to find the average number of hot dogs sold and the average number of sodas sold, how could I figure out both of them at the same time? Concessions, right? Hot dogs and sodas are concessions. So what would I do to figure that out? Well, you would take the expected value from the first one and either add or subtract the expected value of the second one. You would do the same thing for variance and standard deviation if they are independent, only if they are independent. If they're not independent, we can't do this. So you have to verify they're independent. That's why it's capitalized. If those tables are independent of each other. If they're not, we cannot determine the variance or standard deviation. Okay, so make sure if you can use those if you know they're independent of each other. Okay. All right, so let's do example number 1. A large corporation has thousands of employees. The distribution of annual salaries for the employees is skewed to the right, with a mean of 68,000 and a standard deviation of $18,000. Because business has been good this year, the CEO of the company decides that every employee will get a $5,000 bonus. Let X be the current annual salary of a randomly selected employee before the bonus. Y is going to be the employee's salary after the bonus. Describe the shape, center, and variability of the probability distribution of Y. What does Y refer to? When it says letter capital Y, what does that refer to? Employee salary after the bonus. After the bonus. X is before the bonus, Y is after the bonus. So what do we know about, what do I know so far? What do I know besides the stuff I highlighted and underlined? What do I know? I know the mean and standard deviation of X or Y. Do I know the mean of X or do I know the mean of Y? X before, right? Pre. This number here is what they usually, is their average usually. Okay, so I know $68,000 is their usual expected value. The usual standard deviation, oops, not that, is $18,000. What they want to know, that's what I know. And then everyone's getting a $5,000 bonus, right? Okay. So what they want to know is three things: shape, center, and spread variability. What do we know about shape here? It's skewed right. That's referring to X, right? X is skewed right. The pre $5,000. What's the shape going to be after they give $5,000 to everyone? Still going to be skewed right, because why? What shifts? Everyone's getting the $5,000 bonus. It's not like the low end is getting $5,000 or the high end or the middle. Everybody in the company is getting $5,000. So all of those prices, all of those dollar amounts are just shifting, right? It's like now. In California, I think $15 is the lowest. We is minimum wage. Might be more now. $15, that's great, but you also have to deal with inflation. So it's like you get paid more, but it doesn't really mean anything because of inflation, right? So it's the same thing. It affects everybody. So everybody's just going to move down. So the shape is still going to be skewed to the right. What does that mean, skew to the right? Most of the data is on the left. And in this case, what data is that? Most salaries are on the left. That's true of any company. Most salaries are on the lower side. There are some higher ones, but it's only executives and CEOs and stuff like that. And there's not very many of them. Companies don't have very many of them. Otherwise, they wouldn't be around. Okay. Okay. Shape. Center. When I talk about center, what am I talking about? The median or the mean, right? Mean. So we don't know anything about the median. So we can't really answer the median, but we do know stuff about the mean, right? I know the old mean is $68,000. But what they're asking for is the mean of Y. What's the mean of Y going to be? Yeah, it's going to be 68 plus the 5,000 everyone's getting. Right? That's the mean of the new salaries. Spread, variability. Spread and variability are the same thing. When we talk about spread or variability, what are we referring to? Which statistic are we referring to? Standard deviation, IQR, range, those things. Well, we only know anything about standard deviation, so that's variance is another one. Since they only tell us standard deviation, we're going to do standard deviation. We'll use that one too. What is the standard deviation of the price of the salaries after bonus is going to be? Still going to stay the same because everyone got the bonus. Nobody broke away from each other. Everyone's is the same. If they said they're only going to give them to the people who the low end, then the spread would get closer. Or they said they're only going to give them to the high end, that's different, right? That's why you guys heard executives in this country, CEOs in this country make on average 100 times more than the average worker. 20 years ago, that wasn't the same. 20 years ago, they didn't make nearly as much because of this idea. Because CEOs, how they're paid is based on bonuses. If the company does well, they get bonuses, right? Workers don't get bonuses. Workers don't get, you might get once in a while, you might get a bonus or two, but the CEOs get bonuses every year. So their bonuses are pushing their salaries this way, right? The workers staying still. So the CEO is keep constantly going this way, this way. That's why that gap is all still there. That gap's only going to get bigger. Okay, so all right, example number 2 now. Example number 2. Employees selling refrigerators at an appliance store make money on commission based on how many they sell, how many refrigerators they sell. The number of refrigerators, R. So we're not using an X and a Y now. Now we're using R. Sold in a randomly selected hour has the following probability distribution. The number of refrigerators, so in an hour, how many did they sell? There's a 22% chance they're not going to sell any. There's a 31% chance they're going to sell one refrigerator in that hour. 12% chance that they sell two, so on and so forth. Refrigerators are expensive, right? They're over $1,000 easy. So they don't sell many, right? That's why they only sell, the probability they sell 5 in an hour is 2%. It happens, but not usually. So here is a histogram of the probabilities. So the probabilities, 0 is 22, 1 is 31, so on and so forth. Okay. So what I want you to do, so here we go. Oops, sorry, not yet. So on average, how many refrigerators would they expect to sell in an hour? In an hour. In 1 hour, how many refrigerators would they expect to sell? In 1 hour, how many would I expect them to sell? You don't have to do any math to figure this out. You just got to look on the paper. How many would I expect them to sell? Not one. There you go, right there. It's given to you. Between 1 and 2. I'd expect them to sell between 1 and 2. And right underneath it is a standard deviation. I'd expect them to sell between 1 and 2, and that number is going to vary by about 1 or 2. Okay? So at this appliance store, the commission earned is $30 for every refrigerator sold. So if you sell a refrigerator on top of your salary, you get $30 extra. That is C equals total commission earned for a random selected hour. So they have C equals 30 times R. So for every refrigerator you sold, you make $30 extra on top of that. Okay? What shape is the probability of C going to have? This is R right here. This is R. Is it going to have the same shape or is it going to have a different shape? You know what? Let's do that one last. Let's do B first. How do I find the mean of C? The expected value of C. You take the old one, right? Because it said right here. It said C is just 30 times R. This is the average for R. You take the old average and multiply it by 30. They would average 1.72, right? Well, if you make $30 for every one sold, you're just going to multiply that times 30. That's how much you're going to average commission. Okay. What do we get? 51.6. How much money is that? $51.60, right? So what does that number mean? I would expect in an hour to make, if I work there, I would expect in 1 hour to make $51.60. It's not bad for 1 hour on top of what you already make. Okay? On top of what you already make hourly or however they pay you. Okay? That's how salesmen, and saleswomen, that's how they are paid, by commission, so that they work more. So not everyone, if I go into a store or a car lot or a real estate agency, not everyone's paid the same. Not everyone's paid the same. People who are paid more are the people who sell more. That's sales. Okay? So if you sell more, you're good. If you don't sell, then you don't make as much. Okay? Standard deviation. So the standard deviation of C now. So what would I do to find the standard deviation of C? So again, so they're all being multiplied. So is the spread increasing? If the spread's the same, it's going to stay the same. But if the spread's increasing, is the spread going to increase for this if I multiply everyone by $30? So if I give $30 for every one you sell, 0 would stay 0, right? You'd still make $0. 1 would turn into what? $30. No longer 1 sold, it's $30 made. 2 would turn into 60. 3 would turn into 90. 4 would turn into 120. 5 would turn into 150. So before it went from 0 to 5. Now it goes from 0 to 150. Did the spread increase or decrease? Big time, right? So if the spread increases big time, then standard deviation will increase big time. How much will it increase? So before it was 1.36. How much would it increase? Yeah, you just go look right here. If I multiply by a number, I multiply the old expected value and the old, that same number, times standard deviation. So times $30, and you would get $40.80. So if I worked for the store, I would expect to earn $51.60. Does every salesperson get $51.60 every hour? No. Some get more, some get less. That number will vary by about $40.80. If you're a better salesman, you're going to make more than that an hour. If you're not as good a salesperson, you're going to make less than that an hour. Just depends on how much you sell. Okay. Okay, so here, last one we'll do. Last one we'll do is number 3. Oh, sorry. Yep. Let's go back to A. Sorry. That is, yep. Back to A. So if I were to take these values here, this table here, 0, $30, $60, $90, $120, $150, same probabilities, and I were to do the same thing, graphing, what shape would it have? So if I was, this is a graph of the old one, right? 0, 1, 2, 3, 4, 5. I don't have 0 through 5 anymore. I have 0, 30, 60, 90, 120, 150, right? So what, oh, first of all, let's talk about this shape right here. What does this shape most represent? I would say skewed right, because these bars are kind of high. I would say, and then it kind of tapers off a little bit. I would say best represents skew to the right. Not as much as the old one, not as much as the one we did over here, right? The one we did over here, I think would be a lot more skew to the right. They didn't give us a graph, but I think it would be. This guy, it would be approximately skew to the right. My question is, if I were to graph this guy here, would it have the same, different shape? And what would that shape be? That's a good question. If the spread increases, it went from 0 to 150. Would that affect this? Would that affect the shape? What's the only way to figure it out? See, let's look at the picture. So let's look at the picture. Graph it. You have the numbers. Graphing it's the quick part. So instead of 0, 1, 2, 3, 4, 5, we're going to have to go 0. We're going to start with 0 to $30 to $60 to $90 to $120 to $150. There you go. It's the same, just different numbers on the bottom. That's what I was waiting for someone to say. No one said it. Thank you. They would be the same. Same bars, same heights, just different numbers. The x would change, but it doesn't really matter what the x is because we're not looking at the x. We're looking at the bars, the height of the bars. The bars would be exactly the same. Okay. So if we said that one was skewed to the right, we would say the C probability distribution of C would be approximately skewed to the right as well. Why? Because the bars would be exactly the same height. Bars wouldn't change. I'm not changing probabilities, right? To change the bars heights, I would have to change probabilities. I'm not doing that. I'm just changing the x-axis. Okay. All right. So last thing. Here we go. Number 3. Then we'll be done for today. Yes. Okay. So we have a table. Depending on attendance of a minor league baseball team, the number of hot dogs and sodas sold at a game is given by the following table. So, what's the probability that they sell 100 hot dogs in one game? About 5%. What's the probability they sell 200? About 10%. 500, 1,000, 2,500. Mm-hmm. Soda sold. What's the probability they sell? Oh, wait, guys, I need everyone's focus up here. Thank you. Okay, soda sold. Now, hot dogs and sodas are different things, but they're both concessions, right? They're both considered concessions. So what's the expected number of, instead of hot dogs and sodas, because they're not like terms, if I put concessions, they are like terms. So what is the expected number of concessions sold? So we'll say this is X, we'll say this is Y, and we'll say concessions is C. So in other words, they're asking what is the expected C? Well, where can I, if I'm not sure, where can I look? So what am I going to do? I'm going to add the means together. I need this one right here. Find the mean of the first list. Find the mean of the second list. If you're combining them, then you're adding them. If you're finding the difference, then that would be D. But it's saying expected number of concessions. So that's both. So I need to find the expected number of hot dogs plus the expected number of sodas. Oops, not SY. How do I find the expected number of hot dogs? Yeah, you did this on the homework, right? Multiply, 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 add all together. Multiply, 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 add them all together. So what's the expected number of hot dogs sold? Yep, 1,025. And then what's the expected number of sodas sold? 680. That's what I got too. Add those together and we get 1,705 total concessions sold. Okay. How do I do standard deviation? There you go. So I know the formula, but that formula is long. Is there a faster way to do it? How do I use the calculator to be faster? Yep. Use your lists, right? Use your lists. So that one is that.
First one is 793.61.
16. Add that together. 793.016 plus 476.025. 1,269.041. Okay.
Which one? That's standard deviation.
All right.
Like on the same.
All right. We'll stop there for today.